So be super ready for understanding that Vux Hoy. That is super important. Okay? Vux and Hoy. So these are our horizontal lines, zero slope going through the y-axis. These are our vertical lines, undefined slope going through the x-axis. So I have a horizontal line. I have to go through this point, which means I'm going to go through this y value. So my equation is y equals -8. All right, a line with an undefined slope is going to tell me it's vertical. So I'm going to be going through my x value. So this would be x equals 5. And this time I have a vertical line, I know specifically. So again, I'm going to go through my x value. So this is x equals 3. And again, you guys, if you ever get stuck, like I mentioned, draw a little picture. So I'm going to go over 1, 2, 3, up to 20, which, oh my gosh, we're going to just pretend. Okay, so let's pretend that that's 20, and that's 3. Okay, so there's my point, 3, 20. And I want to be a vertical line. So really, if I draw that vertical line, I have to go through that point. And if you notice, I'm just going through the x-axis, which is why my equation is just x equals 3. All right, and then finally we have a line containing the point 5, -1, and the slope is 0. So if I know the slope is 0, I know I have a horizontal line. So if I have a horizontal line, I'm all about the y. So y equals -1. Done. All right, moving on. Okay, so now we want to, on the back, it said to write all of these equations into standard form just to get you guys all prepared and ready. So I have a line that has to go through this, and I have my slope. I have a point, and I have a slope. Oh my gosh, I'm going to start with point slope. Y minus y1 equals my slope, x minus x1. Okay, so here is my x1 and y1, and then there's my slope. So I get to plug all this in. Okay, there and there. I'm just going to go directly below it. So y1 is -1, and this is 4, and my slope is a -3. And now I'm going to go ahead and write the equation. So it's y minus a -1, so plus. And then I have slope, and then it's x minus 4. And here's where I want to distribute. Okay, so this is going to turn into, I got to start writing smaller, y plus 1 equals -3x plus 12. All right, I want to go ahead and I want to move this over. So now I have y equals -3x, and I'm going to be subtracting, so it's plus 11 now. And then to put this into standard form is ax plus by equals c. Okay, so I'm going to just move this on over, and it becomes positive. So I have 3x plus y equals 11. And there's my final answer. All right, so now this time for 11, I don't have a slope, so I actually need to find that first. Okay, so I'm going to start with slope, and that's the change in my y's over the change in my x's. So I have -2 minus -3, but plus, because it turns it. All right, and then that's going to be +1, and then a change in my x's. So 4 minus 6 is -2. Okay, so here's my slope, -1/2. And now I'm allowed to use either point. It does not matter. Okay, but again, I'm going to have y minus one of my points, then my slope, x minus one of the points. So let's go ahead and choose one. I'm just going to go with this first one. Okay, so it's y minus -2, which is going to make it +2, and then -4. And our slope is -1/2. And we have to distribute that. Okay, so y plus 2 equals -1/2 x. 2 negatives make it positive, and half of 4 is 2. And then I want to subtract 2, and oh my gosh, that's going to really just cancel these on both sides. So this is going to be y equals negative 1/2 x. If you want, you could put plus 0. But I need to get rid of this, okay? And if I have a fraction, to put this into standard form, we need to get rid of that. So I'm going to multiply everything by 2. All right, so that gives me then 2y equals, that's going to cancel now this 2 down here. So negative x, and then anything times 0 is still 0. And again, you don't have to put that if you don't want. But then again, we want to move this x to the other side. So I have x plus 2y. And here's where you would want to keep that 0. Know that it does equal 0. And there we are. Okay, so perpendicular. If it's perpendicular, then we know all we're going to do is we're going to look at this slope that's given to us. And we're going to say see ya to the other part of the equation. And if it's perpendicular, it's the opposite reciprocal. I'm going to change my color here. Okay, so a perpendicular slope to positive 3 is going to be negative 1/3. So this is what I have to use, and I also have to use that point that's given to me. All right, so we're going to put up our framework, y minus our point, slope, x minus our point. And the point, we have negative 1, so it's plus 1, negative, and it would be, yep, negative 2 when we place it into the equation. And then we have negative 1/3. And now we distribute. Okay, so y minus 2, negative 1/3 x. Negative times a positive keeps it negative. But now 1/3 times 1 is going to be 1/3. So now I'm dealing with these fractions. Now here's a case where I want to talk about something I didn't talk about in class, but something you could do. Okay, if you know you're going to put this into standard form, I can get rid of this 3 right away. So if I notice I have a 3 here and a 3 here, and I don't want to add fractions because that's the worst, I can multiply everything by 3. Okay, I can multiply this and this by 3, and this by 3. Every single thing by 3. Then it's going to get rid of that fraction and make my life a little easier. So this is now going to turn into 3y minus 6 equals, here's where this is going to cancel these 3's, and that's why we're doing this. So negative x and then minus 1. So now look at that. Super easy to deal with and get into standard form. Let's move this x over, positive, got my 3y, and then I have a negative 1 and I'm going to add 6 to it, so we're going to get with 5. Done. Done, done. All right, a line parallel. Parallel is a little bit easier because that means that it's the exact same slope. All right, so here's the slope, and I'm going to keep that exactly the same. So I'm going to use negative 1/2. Don't care. Don't care. All right, so y minus my point, get my slope, x minus my point. Slope is negative 1/2. Let's plop that in. And the point, x value is 3, so minus 3, negative 2, so plus 2. Let's distribute. So y plus 2 equals negative 1/2 x plus, 3/2. So I did do this one in class, but again, just a little quick tip. Let's multiply everything by 2, Boom, boom. That's going to cancel these out. That's just going to change these. So I'm going to have then 2y plus 4 equals negative x plus 3. And again, pop this over. That's an x plus 2y. And then I have 3, subtract 4, negative 1. Done. All right. Here I have a line parallel again, so again, same slope, but here's where this is not in slope-intercept, it's in standard form. So let's go ahead and move over the 4x and then divide everything, so everything's going to change signs. So we have y equals 4x plus 4, because we just divided everything by negative 1, negative, negative. Okay, so these were all negative, now they turned all positive. Perfect. So the slope of this is 4, and we're going to keep it that way because we have parallel, which means the same. All right, so I'm not going to keep popping on all these colors. It's going to be faster if I don't. So y minus 0, my slope, x minus 0, because all I did was place these two in. So y equals 4x. If I need to put it into standard form, then remember we want to keep our x positive. So what I'm going to do this time is move the y here. So this is 4x minus y equals 0. Okay, perpendicular. All right, again, we got to move this. So we're going to go with y equals negative 6x plus 0. But the slope is perpendicular, so it's not going to be negative 6. We're going to take this, throw this away, and then we're going to say, oh yeah, it's got to be positive 1/6. And then we have to use this point. So I have y plus 12 equals 1/6 x minus 2. All right, distribute. Y plus 12 equals 1/6 x. And then here's where we are going to have 2/6, okay? And again, I think I'm going to just leave this like this. And yes, that can simplify, but I don't want that fraction anymore, okay? So I'm going to put it into, because I want to put this into standard form. So that would simplify to 2/3, and then when we'd have to add this, we'd change everything. But let's just multiply everything by 2. I'm sorry, not 2, 6. Okay, so here, multiply, which is going to cancel. But then multiply 6 by y and 12. So I have 6y plus, that would be 72. Yep, okay, so 72x and 12. Okay. Oh, not 12. Hello, that canceled the 6, so that's just a 2. Okay. Anyway, we're going to keep going here. We want x to be positive, so actually what I'm going to do is I'm going to move this 2 over here and make this 74. And then we're going to subtract the 6y. And there's my standard form. Okie dokie. All right, last thing. Now we want to determine if A and B and C and D are parallel. So here's A and B, and then we have C and D. Okay, so those are going to be little segments. And we want to know if they're parallel or perpendicular. So obviously, to deal with that, we got to figure out the slope. All right, so the slope here, we're going to go ahead and find the slope. And so the slope of this would be 11 plus 4, because it would be minus a negative, and then 2 minus negative, so plus 1. So I have 15 over 3, which is 5. Okay, C and D, we're going to go ahead and find that slope. And that's going to be 10 minus 1 over 4 minus 1, which is going to give me 9 over 3, which is 3. So both slopes we have totally different. So these are neither. Neither. All right, so again, here we have AB, and we're going to find the slope. So I'm going to go ahead with negative 2 minus 8, and then negative 1 minus 2. So this is going to give me negative 10 over negative 3, which is going to turn those positive. Okay, and then we're going to go ahead and we're going to look at C and D. So my second slope, negative 3 minus 7, and then 0 minus 3. So this is going to give me negative 10 over negative 3, which would be positive. These are exactly the same, which means I have parallel lines. All right, that's it. So let me know if you guys have any questions for tomorrow.